In this video, we're going to go over how to simplify compound circuits, which are series and parallel circuits mixed together in one circuit, into a series circuit to make it simpler. This will also shed light into how to simplify a circuit that is parallel and how to make that series. This can come in handy in many circumstances. For example, if you're solving for impedance and you're using inductive and capacitive reactance and you have a series circuit, well, the formula for that's pretty simple. But if you start to get into a parallel circuit, the formula for that is a lot more complex. Okay, so there's a lot of applications where this can be useful. That is one example. Here we're looking at two different types of your compound circuits. So in the first one, we can see a resistor, and it is in series with a branch of two other resistors that are in parallel with each other. So we can see the first resistor in series, it branches out to two other resistors. These are in parallel, and then you see the branch back in, of course, to where then the circuit ends. We see the second circuit, and we can see there's also a branch, but here it's right away. The circuit branches into two separate sections to where we have these two sections in parallel with each other. The difference is these two circuits on the left side are in series with each other, and these two are in parallel with this resistor here on the right that is by itself, but again, it is in parallel with these other two resistors that are in series. So we see the difference here. And that is where we simply have a section of the circuit that would be in series with another section that would be in parallel, or our second version where we just have two separate sections in parallel with each other, but in those separate sections there can be resistors that are in series with each other. You could imagine more resistors on the left and right sides, for example, in series, and those would still all be in parallel with each other. By now we should already know the formulas for solving resistors in series and parallel separately. So if you don't know that, I'll link some videos down in the description. I'll also link another compound circuit video down below, and the goal of that one is a little different. We're solving for certain things instead of actually having the goal of simplifying everything into a series circuit. So that might solve as another good learning lesson. So if we analyze this circuit, let's just see what we're looking at. We see R1 and R2, these are in parallel with each other. And then R3 is in series with R1 and R2. We see simple numbers, it's all just 10 ohms. So all that we're going to do is isolate the section of the circuit we want to simplify. And in this circumstance, if we want to make this a series circuit, well, let's simplify this section that is two resistors in parallel. To do this, we're just going to solve for the total resistance between these two resistors. And to do that, we're going to use the formula for finding the total resistance for parallel resistors, of course. So I'm going to call it R total as RT with the lowercase t, just so we know it's not the total of everything. I would do a capital T. So to find the R total of R1 and R2, we're simply going to get 1 over R1 plus 1 over R2. I always stick with the same formula. There's a separate formula you can use for two parallel resistors, but why memorize all these different formulas if you don't have to? So we're going to get this. We're going to add it together and solve for it. That's going to give us the R total, but we're also going to do 1 over that number, and that will give us the actual total number. Of course, with math, sometimes it's more confusing when you explain than when you actually just solve for it. So simply, we're going to do 1 over 10 plus another 1 over 10. We're going to get that total number, and we're going to do 1 over that number. 1 over 10 is 0.1, and we have that twice, so 0.1 plus 0.1, that's going to equal the 0.2. And of course, we're not done yet. We still have the 1 over. So we have 1 over 0.2, and 1 over 0.2 equals 5. Now we're looking at 5 ohms, which is the R total of the R1 and the R2. Now we can get rid of the parallel resistors, and now we can replace it with a resistor that's going to be just one resistor in series with the other resistor now, because we have the R total of those two. And because it's just R1 and R2 mixed together, I'm just going to call it R equals 5 ohms. We don't have to think too much about renaming it, and that signifies the fact that it is a simplified version of something that was more complex. Okay, so now we see the circuit is simplified. So now if we want to find R total, we could just think, okay, if we have a series circuit, we're going to have the R1 plus R2. In this case, we're just going to be looking at 10 plus 5. And we see we get 15 ohms as our R total. Next, we're looking at this other form of the compound circuit, where we have these branches of the two separate sections in parallel with each other. But we see these ones on the left are in series with each other. So we see R1 and R2 in series. Simply, we're just going to combine them. We know that we just do R1 plus R2. I mean, this one's super easy, but we're just doing 10 plus 10 equals 20 ohms. And that is the R total of the left section there. Now, just like before, since we simplified this section, we can now get rid of this section. And now we can replace it with one resistor that is going to have the R total. So we'll just call it again R equals 20 ohms. Okay, and because we have the R equals 20 ohms for this resistor and this resistor, we see they're both in parallel now. So we simplified it, but now they're still in parallel. So the whole point of this is how to simplify everything into the series level. So now we can simply solve for this. Like if we just had two resistors that are in parallel with each other, R1 is 20 ohms and R2 is also 20 ohms, because we see it's still in parallel with each other. So we're just going to treat it just how it looks, and we're going to do 1 over 20 plus 1 over 20, and that's going to equal our R total, but we're going to have to do 1 over that number to get our actual R total. Okay, so let's get into it. 0.05 plus 0.05 is going to give us 0.1. Of course, we're going to have to do 1 over 0.1. We're going to get 10 ohms for the R total. Now, again, we're going to get rid of what we just simplified. Now we simplified everything to one resistor, where we just have the R total, and that is the 10 ohms. Now we're going to be looking at some questions. We're going to find R1 and R2 total, and then the R total of everything. Since R1 and R2 are in series with each other, and we'd like to simplify that, we're simply going to do R1 plus R2, which is going to be 30 plus 10. That's going to give us a total of 40 ohms. So we see we solved R1 and R2's total, 40 ohms. Now in real life, you're not going to redraw everything, so I'm not going to redraw it. We already know what the R total of these two are. So now we're going to think about it, just like if this was an actual test. Now we combine these. This is 40 here, and then we have 20 here. So we have those in parallel with each other. Because of that, we're simply going to do 1 over 40 plus 1 over 20. We're going to get that total answer, and we're going to do 1 over that. 1 over 40 gives us 0.025. 1 over 20 gives us 0.05. When we add those together, we get 0.075, but we still have to do 1 over that. When we do 1 divided by 0.075, we get the R total of 13.3 repeating ohms. Just going to simplify it. Call it 13.3, and there we solved for the R1 and R2 total and the R total. Okay, our next question, we see the other type of circuit that is compound, where we have the first resistor in series with a branch of two other resistors, where those two other resistors are in parallel with each other, but that is, of course, in series with the resistor before. Okay, so we're going to want to combine these two resistors that are in parallel with each other. So we're going to use the parallel resistor formula to solve for them. So we're going to do 1 over 20, which is going to be the R1, and then that is going to add to 1 over 30, which is going to be the R2. That's going to give us the total number, which we're still going to have to do 1 over that. 1 over 20 is going to give us 0.05. 1 over 30 is going to give us 0.03 repeating. When we add those together, we're going to get our 0.08. But since we had that 3 repeating, I'll end it with a 3 repeating. So 0.083 repeating. The significance of that is if you want to get closer to your answer, instead of doing 0.08 or 0.083, you're going to do 1 over 0.08, and you're going to type 3 maybe 10 or 15 times in your calculator, and you're going to see you get the number 12. Of course, in this case, you didn't have to type 10 or 15 of the 3s. It's just basically when I'm working with a repeating number, I will spam that number in my calculator and then I'll press enter and it will always get you closer to the answer. As if you do just 1 over 0.083, for example, nothing repeating, you're going to get the answer 12.04819277. It keeps going on. And we see we end with the actual whole number of 12. Of course, that is 12 ohms. And now we have the answer for the first part. R1 and R2 is 12 ohms. Now again, like a test, I'm going to think about this as not rewritten, but I'm just going to think about, okay, now I have these two combined as 12. So now we see that we have 10 and 12 in series with each other. So we're simply just going to take R3, the 10 ohms, and we're going to add that to the total of the R1 and the R2, which is now the 12 ohms. And we're going to see 10 plus 12 equals 22 ohms. And that is going to be the actual R total. And now we have the answer for the part 2 of this question. And that's it for this video. It's pretty simple and straightforward, but that's the whole notion of this, is now you can do this to much more complex problems, and you can simplify things to where you're not going to have to memorize a bunch of different formulas. If you think series and parallel for a bunch of different things, you can start to just memorize your series formulas for a lot of things and then simplify your actual circuit. Thanks for watching this video. If you like it, give it a thumbs up. If you had any questions, leave that in the comments. And if you want to personally contact me at this email right here. Until next time, take care. Goodbye.